Good morning to our panel, Dr. Muhammad Shahir, Dr. Muhammad Amri, and Dr. Amma. My name is LENI Anak ENGGONG, number MATRIC B0517100043. The title of my project is Particle Swarm Optimization Best Algorithm for Minimized Surface Roughness in Rotary Ultrasonic Assisted Milling of Hardened D22 Steel. My SV is PN Dr. Raja IZAMSHAH bin Raja Abdullah. The problem statement of my project is the hardened steel is one of the materials that widely used to produce dies and mold. However, these materials are considered as difficult to cut and complex tool for forming processes that causes higher wear, shorter tool life, and low surface. The objective of my project is to optimize the rotary ultrasonic assisted milling, machining parameters, speed, feed rate, depth of cut, ultrasonic frequency, and vibration amplitude using particle swarm optimization technique. Second is to validate on the effectiveness of the developed optimization model. Methodology. So this is the flowchart of the research on how the research are conducted from start to end. The experimental setup of rotary ultrasonic assisted milling. So this is the machining parameter that I use in this experimental test. So there's a 5 parameter, which is cutting speed, feed rate, depth of cut, frequency vibration, and amplitude vibration, where the slurry concentrations are fixed at 10%. So there are the level of independent variable of this machining parameter. So there's a 3 level. So this is the flowchart of the PSO where the method are applied. There is also the algorithm of the PSO. Step of the algorithm is the first, generate the initial swarm involving n particle at random. Step 2, generate the initial velocity randomly. Next, find the best solution that has been achieved so far by that particle and its best value obtained so far by any particle in the neighborhood of that particle. Step 4, update the velocity and the position. And step 5, stop if the termination condition is satisfied, or else go back to the step 3, result and discussion. So this is the response surface methodology RSM, statistical ANOVA, and the mathematical model development. The probe F were less than 0.0500, indicating the model's terms are significant, and in this case, the strongest machining parameter factor that affect the cutting force value in the design space are denoted at A, B, C, D, and E. At the below of the table, we can see the mathematical model development for the RSM RA. The statistical diagnostic test. From the normal plot of residual, it can be observed that the residual follow a normal distribution in a scatter plot straight line. It can be observed that from predicted versus actual plot, the points are divided by 45 degrees in randomly scattered, confirming the model fitness. Third and fourth graph, which is the residual versus predicted plot and the outlier T, are displaying a randomly scattered but in a constant range of residual throughout the graph. 3D surface response plot. The first graph is the interaction between cutting speed and feed rate on surface roughness. The 3D plot shows that the lowest surface roughness, RA, is located within the region in which cutting speed is high and has low feed rate. The second graph indicates the interaction between cutting speed and depth of cut on the surface roughness when the feed rate is constant. This shows that the lowest value of the surface roughness happen on the region of the highest cutting speed and lower depth of cut. The particle swarm optimization. The upper table indicate the PSO and the table at the bottom is indicate the RSM result. So from the performance of PSO on surface roughness suggests the best value at 0.1 at 394 compared to the performance of RSM surface roughness value at 0.1 at 9814. So this shows that PSO give more optimum value of surface roughness with the combinations of depth of cut 10 micrometer, the frequency vibration 27 Hz, and the vibration amplitude at 3 micrometer compared to the RSM with the combinations of depth of cut 22.37 micrometer. The frequency vibration is 26.99 Hz and the vibration amplitude at 2.98 micrometer. The PSO are slightly better accuracy than RSM. It can be demonstrated by comparing their efficiency. The best fitness value of the surface roughness value for RSM and PSO was 0.189814 and the 0.18394 respectively. So in this case, PSO has a slightly better accuracy in predicting the value of the surface roughness than RSM. From the analysis, the PSO fit the experimental data with an excellent correlation compared to the RSM model. It can be seen from the previous table that both models perform practically well, but PSO perform consistently better than RSM. The performance of the PSO. Here we can see the graph for the PSO best fitness versus iterations. So by using the equation resulted in RSM that we obtained before from the RSM, the PSO algorithm was created in MATLAB software. All the required parameters are inserted in the programming and the result was generated. The result acquired as shown in the best fitness value of 0.18394 was lowest at the 100 number of iteration. As seen from the graph, the value increases at the beginning. However, with the increase of the iteration, the value of best fitness remains constant. RSM estimates the relationship between the variable parameter and response where it adjusts the concentration of multivariable to achieve the optimum concentrations of the response. However, RSM has some limitation. In the case of large number of variables, the interaction between the factor variables and the response will increase the complexity of the feasibility of the method will be challenged, according to Pata 2005. So due to the advantages of the RSM, several optimization algorithms have been presented over the past few decades. So according to the PAL 2009, one of the optimization algorithm is particle swarm optimizations, where PSO have many advantages over other optimization, such as generally easy to program. PSO also offer a more attractive choice to optimize non-linear and non-continuous problem with multi-variable, according to Wana 2008 and Abdel 2005. The predictive ability of the statistical approach RSM and PSO were compared using dataset of 27 experiments run. The predictive optimization ability and sensitivity analysis of PSO were used to validate the result. So the experimental finding revealed that using PSO-based approach achieve high accuracy correlation, which indicate that the result performed practically well. Lastly is the conclusion. So there are two optimization techniques, RSM and PSO, were applied for method optimization in order to generate the best value of surface roughness, RA. So based on the experiment in this study, PSO has advantages over the RSM technique. The PSO method demonstrated more accurate prediction than the RSM method. Thus, it can be concluded that artificial intelligence methodologies such as PSO may propose a better alternative for optimum best value of surface roughness method optimization than the more widely used RSM method. That's all from me. Thank you.